Good afternoon.
Good afternoon, madam.
Okay, can you all hear me clearly?
Yes, madam.
Okay, what about my screen? Can you all see?
Yes, madam.
Okay, then let's start. In last week or in the last session, we were discussed about relational entity relationship and the object-oriented data model as well as other data models. And in final lecture, we were discussed about logical structures and the case in the relational model and about relational algebra. So today let's discuss about relational database model. Okay. Before that, do you have any question from the last session? I will give you 2 or 3 minutes. If you have any doubts about previous session, now you can raise your questions.
Good morning, ma'am. Sorry, good afternoon, ma'am. I have a doubt.
Yeah, you can.
Okay, a single value attribute, no need to be, in the book it says,
Yeah,
so if it's a single value attribute,
yeah.
no need to be a single, simple attribute. It can be a composite attribute also.
Yeah,
So can you give me an example for that one?
that means I didn't get your question clearly. That means single attribute. As an example, let's take a single entity like this, student. Okay, consider about name. We can divide this name into last name, first name, and also surname likewise. Okay, so when consider about this one, these are simple attribute, but it is belongs to this composite attribute. So what is your problem?
No, my question is, in the book it says, single value attribute is not necessarily a simple attribute, which means it can be a composite attribute also, no, ma'am?
Yeah, it can be a
So yeah, that's why I just need a explanation about it.
value.
It means composite attributes are always going to have some subdivided
Yeah.
attribute.
Don't. That means you are talking about simple or single.
I'm talking about both.
When consider about single value, it can be a composite attribute. Example is a telephone number. When consider about telephone number, it is belongs to single value attribute. But you can see there are so many telephone numbers can be exist. So it is belongs to composite attribute. Okay.
No, if it's a single valued attribute, it can hold only one value for one entity occurrence. So
yeah,
when it comes to,
yeah.
Yes, ma'am.
Yeah, you can continue.
Yeah, so when we consider about the composite attribute, however, it's going to have some subdivided. So when those subdivided attributes are filled with a value, so it means that particular entity occurrence will have more than one value, no, ma'am?
Yeah.
So how it is going to be a single value attribute?
In which page, Puta?
In page number 53.
53 page.
Yes, ma'am.
Paragraph. Which paragraph? Paragraph.
Excuse me, madam. Madam, we can't hear you, madam. Madam, sorry, madam, we can't hear you properly.
Now is it okay?
No, ma'am, the sound is
No.
very low.
So now,
Ah,
Now,
no, okay, ma'am.
okay. Then which paragraph?
in the single valued attribute, that's a paragraph and
Can,
third sentence.
for example, person
That keep in mind that a single value attribute is necessarily a simple attribute.
not necessarily a simple attribute. Yeah.
Yeah.
Single value attribute, not necessarily a simple attribute. Okay.
Okay.
When consider about a simple and a composite attribute, when consider about the attribute, if we cannot subdivide it into another attributes, it is known as a simple attribute. Composite attribute can be subdivided into other attributes. Okay.
Okay.
In this case, it's talking about a single value attribute. When consider about a single value attribute, it can hold only one value. But when consider about a multi-value attribute, it can be hold many values. In this third, one, two, three, no? Yeah.
Yes, ma'am.
In third paragraph, keep in mind that a single value attribute is not necessarily a simple attribute. Simple value attribute, single value attribute එක simple attribute එකක් වෙන්න ඕනේ නැහැ කියලා.
Sorry, ma'am, I don't understand singular.
Okay.
Which means it can also be a composite attribute, isn't it, ma'am?
Yeah. Single
So
value
that's the
attribute.
question, ma'am. If it comes to a composite attribute, however, it's going to hold more than one value, no, ma'am.
No, okay,
Each attribute.
now I got your question. As an example, let's take name. Okay.
Okay.
Then now name can be divided into three parts as last name and the middle name and the surname. Okay.
Okay.
Then let's take another example, telephone number. Okay. This name belongs to single value attribute. Okay. Is it clear? This one is belong to multi-value. When consider about last name, it can hold only one name. This is a composite attribute, but it can only hold one value. When consider about you,
Ma'am, excuse me.
yeah.
Here, last name is going to be a simple attribute and the name is going to be a composite attribute, isn't it?
Yeah.
The one which is going to subdivide it.
Yeah.
So name is a composite attribute.
Name is a composite attribute, but when we subdivided it into a last name, middle name, and surname, last name is a
Simple.
attribute. So simple attribute can hold a single value.
Okay.
Okay.
But when it comes to name, it is going to have these three values now within it.
So in our ER diagram or database we consider these three. Because this one is subdivided into three. These three now in table, we indicate last name, first name, and the third name. So this composite attribute can be divided into a simple attributes. Then simple attribute can hold only one value.
So however, it is going to be a simple value. Sorry, simple attribute.
Yeah, this is a simple no Puta. This attribute is a simple and it can hold a single value.
Yeah, I got the point, but the book is still confusing. That's why.
That a single value attribute is not necessarily a simple attribute. Yeah. You can see, then we consider about this a composite. Sorry, other one is
Yeah.
okay. Page 30. Yeah. Other one is page 73, 76, third paragraph has a good description. You can go through that also. So when consider about this composite attribute, it can be subdivided into simple attribute. When consider about a simple attribute, it can hold a single value. Okay. Again, let's take this one, telephone number. Telephone number can hold simple. This is a multi-value. Someone can have one phone number, or someone can have multiple value. So it is not needed to have a composite attribute. That means a composite attribute can be a simple value or multi-value. Can you see it? Who is this one? 6 2. Is it clear?
Yes, ma'am.
Can it's not necessary to be a simple attribute. Is it clear, or do you want me to explain it again?
Sorry, ma'am. we
Madam,
couldn't
your
hear it
voice is
clearly.
not clear now.
Now, please give me 1 second. Okay. Can you all hear me clearly now? Hello, can you all hear me?
Yes, ma'am, but
Yes,
the
ma'am.
sound is still low.
Hello. Now, it's okay now. What about now? Hello? Now can you hear me?
Now, okay, ma'am.
Okay. So what about this question? Is it clear? Okay. What about now? Is it okay?
Yes, ma'am.
Okay, then let's continue from the last point. If you have any doubt, you can drop a message to a chat box. Then let's discuss about relational database model. In this relational database model, you all know the basic data structure is a table. So when considering about a table is consist with series of columns and the rows. Then the intersection point of a column and a row is known as a cell. Can you all see my screen
No, ma'am.
now?
Now, okay, ma'am.
No, okay.
Okay, so you can see this table is known as a relation. In relational database model, table can be in relational database model, tables are known as relations. When considering about table is consist with rows and columns. Okay, so the intersection point of a column and a row is known as a cell. We use this cell to store the values. Okay, in this example, let's discuss this relations or a relation database model with an example. You can see there are two tables as customer table and the agent table. When considering about this customer table is consist with 7 attributes as course code, course last name, then the course first name, course init, and the course phone, and course not course, customer code, customer last name, customer first name, customer initial name, and the customer phone number, and their renewable date, and the agent code. Then when considering about agent table, it is consist with agent code, agent last name, agent first name, agent initial name, initial name, and the agent phone number. So when considering about both table, you can see this agent code is common for both tables. Okay, so can you identify the primary key of customer table? What is the primary key of customer table?
Customer code.
Customer code is the primary key of customer table. So the agent table, what is the primary key of agent table?
Agent code.
Agent code. This agent code is not a primary key. It is a foreign key because this is a primary key. So when consider about customer table, what is the foreign key of this customer table?
Same agent code.
Yeah, agent code is the foreign key of this customer table. So this agent code is used to create a link between customer and the agent table. So by using this foreign key, we can identify the agent who works for each and every customer. As an example, let's take this customer. This is Anil Pereira. When considering about this Anil Pereira, this 502, that means Ravi Alvis. This Ravi Alvis works for Anil Pereira. So the agent who is assigned for Anil Pereira is Ravi Alvis. By using this foreign key, we can generate a relationship between these two tables. Okay. So when we consider about the relationship between these two tables, you can see when considering about one attribute or one particular customer from the customer table, one agent is assigned for each and every customer. So the relationship between customer and the agent. So when considering about one customer, it only has only one agent. But when we consider about one way agent, 501, he is works for Kumarayappa, and also he is work for Ganga Silva. So when we consider about one agent, this agent is works for many customers. Okay, so this relationship is one-to-many relationship. Okay, then when considering about the link and the relationship, we can define a relation schema by using the relationship type. I already discussed about one-to-one relationship and about one-to-many relationship and about many-to-many relationship. These relationships are mostly or often shown in the relational schema. Before that, you can see this is a relational schema which is created by using Microsoft Access. This is a relationship schema which is created by using Microsoft Access. In this relationship schema, it clearly represents entities as well as relationship time. So when you are creating a relational schema, it is needed to indicate entities as well as relationship time. So according to our previous example, this example, customer and the agent. So customer, as example, let's take agent works for a customer, or customer can handle the age or any relationship. So when we consider about the relationship time between this customer and the agent is one-to-many. So by using this relational schema, we can indicate one-to-many relationship. When consider about one agent is works for many customer. Okay, is it clear? In relational schema, we discuss about or we represent entities as well as relationship type. Relationship type can be one-to-one or one-to-many or many-to-many. So when you are drawing or when you are writing a relational schema for a given scenario, you need to indicate entities as well as relationship type. So this diagram is a relational schema in Microsoft Access. In Microsoft Access, they use this kind of diagram to represent the relational schema. These are the entities, these are the attributes. By using this connection, it describes the relationship type between these two entities. This relationship type is one-to-many. In Microsoft Access, many is represented like this. Okay, is it clear? Is it clear? Can someone answer my question? Is it clear?
Yes, madam.
Then let's discuss about the relationships types within this relational database. After that, we are going to discuss about ER diagram. Then we are going to discuss about converting the ER diagram into database. Before that, you need to have some idea about relationship type and the relationship schema available in the databases. So first of all, according to the slide, we are discussing about one relationships. So yeah, the first one is one-to-one relationship. So when we consider about one-to-one relationship, always we are discussing about binary relationship. In last week, we were discussing about unary, binary, and the ternary. But today we are discussing about binary relationship type. So when we consider about one-to-one relationship, one-to-one, there are two entities like this, and they have a relationship. Relationships are indicated by using diamond shape in ER diagram. You can indicate the relationship type as one-to-one. That means simply one entity can be related to only one other entity and the vice versa. Okay, as an example, our common example, we can take dean and the faculty. So when considering about faculty and the dean, sorry, let's take dean and the faculty. Dean, then the faculty, dean holds deanship in the faculty. So one dean can be assigned to one faculty when we consider about one faculty. So one dean hold a deanship for one faculty. When we consider about one faculty, it has only one dean. So this relationship is one-to-one relationship. Okay. Is it clear? One-to-one relationship. I think now you can identify one-to-one relationship, one-to-many and many-to-many. We already discussed about relationship types in our previous lectures. Then there is another example. In this example, you can see you are going to manage a database for a company. That companies consist with the pilots, accounts, mechanics, and the clerks, salespeople, service personnel, and so on. There are so many employee categories available in this company. Okay. Now you can see accounts, mechanic, clerks, salesperson. But when we consider about pilots, okay, when we consider about pilots have many attributes that the other employees don't have. As an example, some pilots have license number, license, that means license and their license numbers, and the medical certificate and the flight experience records. So these attributes are not common for, these attributes are not relevant for these accountants, mechanics, and the clerks, salesperson, and so on. So at that time, we are going to create another table, or we are going to create another table as a pilot, or not in table or an entity as a pilot, and we can include all these attributes in that table. Okay, then we can create a link between the employee table and the pilot table. I'm going to, this is available in your book. Table is available. It's not available in your book. Okay, you can see this now. Wait. You can see in this company, there is a table as an employee. In this table, employee ID, then the employee number, then the salary and their designation, and so on. But when we consider about a pilot, that means people who are belongs to pilot category, it is needed to maintain pilots, that means medical records and their pilot, that means flight history and their license numbers and so on. So that attributes are not relevant for clerk and the accountant and other salesperson and so on. So we are going to create another table which is known as a pilot, and we create pilot, that means pilot license number, then flight history, then medical records, and we can create a link between these two tables. Okay, so but when we consider about the relationship between these two tables, the employee and the pilot, you can see the relationship is one-to-one. Employee is a pilot. Employee is a pilot. When we consider about a employee, one employee can be a pilot. When we consider about one pilot, it is definitely belongs to a one employee in the company. So the relationship type between these two is equal to one-to-one relationship. Okay, is it clear? You can use, okay, before that, you can say this is employee number, employee ID, employee name, salary designation. So this in this pilot table, pilot flight number and the flight record, medical records, and so on. So can you guess or what is the common attribute for these two tables?
Employee ID.
By using employee ID, you can create a link between these two tables. Okay, so the employee ID is a foreign key of, or you can take this the pilot ID and you can include the not like this. You can create the employee ID as a foreign key of this table. Okay, when we consider about employee ID, employee table, employee ID is the primary key. So when we consider about pilot table, this employee ID become as a foreign key of the pilot table. Okay. Okay. Then about one-to-many relationship. We already discussed about one-to-one. Is it clear or do you have any doubt?
Yeah.
Okay, then let's discuss about one-to-many relationship. One-to-many relationship, as an example, let's take a painter and the painting. So painter paints painting. When we consider about one painter, in last week I think I discussed about cardinality. So when we consider about one painter can. So when we consider about one painting, it is belongs only for one painter. And when we consider about a painter can paints many paintings. So you can see the highest value is many and highest value is one. Then this relationship is one-to-many relationship. So one painter can paints many paintings. So the relationship type between the painter and the painting is equal to one-to-many. So now we are going to create a table for this painter and the painting. You can see this is the painter table and this is the painting table. So the painter, you can see painting number is the primary key of this painter table. Apart from this, you can see paint last name, painter first name, and the painter initial. And when consider about painting, painting table, painting number is the primary key, then the painting title and the painter number. Okay, so this painter number is the foreign key of this table. So when we consider about Sunil Silva, the painter number is equal to 123. So you can see Sunil Pereira paints already painted Down Thunder, then the which one, Vanilla Roses and the Hasty Exits. These are the paintings done by this Sunil Silva. So the relationship between these two tables is equal to one-to-many. You can see one, when consider about one entity from this table, it is linked to many entity from this table. So this relationship is one-to-many. The painter number is the primary key of this painter table and the painting number and the painting number is the primary key of this table and the painter number is the foreign key of this table. So this is about the description about these two tables. You can go through this description, no need to discuss it again and again. You can go through this slide. Then you can see this example. There is another example. An accounting course might have 3 classes offered on Monday, Wednesday, Friday. Okay. Then from 10 a.m. to 10:50 a.m. So you can map this scenario into ER diagram in your exam. That means CAT exam, you can have a question with the scenarios. You need to map it into a ER diagram as well as you need to convert it into a relational schema and you need to normalize that one. Okay. Your CAT exam will be held on 16th November. Let's try to finish all the syllabus before, not all the syllabus, until, yeah, let's try to finish until database tables and the normalization. So after that, you can paste your CAT exam in well proper manner. Okay. So you can see in this case, you can see accounting course. When you consider about accounting course, this course might have 3 classes in Monday, Wednesday, and the Friday. Now we are going to map this scenario into ER diagram. So can you identify the entities? When we consider about this scenario, can you identify the entities that need to map into ER diagram? So what are the entities available in this scenario?
Class
Yeah.
and course.
Yes.
Course. So course and the class is the entities available in this scenario. So you are going to map the relationship between course and the class. When we consider about course has classes. So one course can have one course have 3 classes. When we consider about one class, it is belongs to one course. So the maximum cardinality is equal to 1. Maximum cardinality is equal to 3. 3 means many. In ER diagram, we represent this 3 as many. If the value is more than 1, we take it as a many. So 1 to many relationship. Okay, you can see these are the 2 tables. So then you can convert this ER diagram into a table like this. You can see there are 2 entities. That means 2 tables as course table and the class table. When we consider about course table, it is consist with 4 attributes: course code, department code, course description, and the course credit. So you can take course code as the primary key of this table. And this is about class table. When consider about class table, class code is the primary key. You can see this is the primary key, and you can take this course code as the foreign key of this table. Okay. So it is needed to So when we consider about these 2 entities, as an example, let's take this one, ACCT 211. When we consider about this accounting 1 course code, you can find this one. Yeah, 211, this one. You can find there are 3 classes available for this course. The class code is equal to 1012, 10012, 10013, 10014. So these 3 classes are belongs for accounting 1. That means accounting 1 subject course has 3 classes. Okay, like this, you can see the relationship between this course and the class by using course code attribute. So this course code attribute act as a foreign key of this table. So it is, before that, no need to put your student numbers and the name into the chat. Then so when we consider about one to many relationship, just make sure that the primary key of the one is included as the foreign key of the table of the many. So when we consider about the relationship between 1 to many, you can see there are so many attributes in this side, and there is a primary key as P1. It is needed to indicate primary key of this side as the foreign key of this side. So primary key of one side can be, not can be, for primary key of the one side can be included as the foreign key on the in the many sides. So it is very important when we consider about one-to-many relationship. The primary key of the one side needed to include or insert as the foreign key of the many side. Okay, that is compulsory when mapping one-to-many relationship into a relational schema. So this is the description about these tables. So you can go through this. Then let's discuss about M2N relationship. So when we consider about M2M, that means many to many relationship. This is more troublesome proposition in the relational environment because ER diagrams not allow to maintain one many-to-many relationship. So we need to convert this many-to-many relationship into one-to-many relationship. So no need to put your student numbers and the names into the chat. So you can see the, yes, go. Okay, you can
In page 92,
yeah, page.
the last paragraph, it says the composite key that is composed of course code and class section forms a candidate key. Can you explain that, please, madam?
One, page number 93.
92.
92. Okay.
92.
Yeah,
The last paragraph, the last sentence.
the one-to-many relationship easily. This is about cars and the horse. No? This one. Give me 1 second. Stop, no?
The last sentence, madam.
Not last one, no? Last paragraph or before?
No, before.
Okay.
In other words, the composite key that is composed of course code and class section forms the candidate key.
So when we consider about table, okay. When consider about, can you all hear me?
Yes, ma'am.
Okay, so you can see this is about candidate key. So what is meant by candidate key? What is the purpose of candidate key, or what is the responsibility of the candidate key?
It is qualified to be as a primary key, but not selected.
Selected as a primary key. So you can see when consider about class code, that means we can use this attribute to identify each and every records in uniquely, because there are no any duplicate values in this column. Okay, in class code all the values are unique, so there are no any null values, so we can use this as a primary key, and there are no any duplication values. So but when we consider about this class, that means course code and class selection as a that means when consider about these both attributes, that means course code and the class section, you can see when we consider about this, first of all, you can consider this course code. You can see there are three ACCT 211. So there are some duplication values. But when we consider about this one with this one, that means this attribute with this attribute, you can see these are unique. This record is unique, this record is unique, this record is unique. So when we consider about these two, they are also unique. When we consider about both together, okay, these are also unique. Okay, so we can take these two as a composite, sorry, these two as a primary key, but we select this one. These two are qualified to be a primary key, but the designer selects this one as a primary key. Okay, that is meant by candidate key. So these can be taken as a candidate key, but designer does not select it as a primary key. He or she selects this as a primary key. Is it clear now?
Yes, madam. Thank you.
Okay. Then let's discuss about, I think this one, no? Yeah. Many-to-many relationship. So when we consider about many-to-many relationship, this is complex scenario. It is in ER diagram. They are not able. That means most probably we represent this M2N. That means many-to-many relationship as a one-to-many relationship. In last week we were discuss about this type of example. Before that, you can see this is end-to-end relationship can be implemented by breaking it and produce a set of one-to-many relationship. In ER diagram, they are not. There are some restriction, and in that restriction, they are not allow you to insert M2N relationship into your ER diagram. So it is needed to convert this M2N relationship, that means many-to-many relationship, into one-to-many relationship. To convert this one, you can see this example. Student take class. So one student can take many classes. When we consider about one class, there are so many students in that class. So this relationship is many-to-many relationship. Okay, now we are going to create, before moving, that means before decompose this end-to-end relationship into one-to-many, let's draw two tables for these two entities. Let's take this one, this student table like this. Fernando, these are the classes, and Leonage, these are the classes. And you can see this is the student table and this is the class table. You can see there are so many duplication values. Same value is duplicate. You can see this row and this one, this one. So you consider about these two. There are so many duplicate values. So it is there are so many duplicates value. So we need to avoid this duplicate value or a data redundancy. So the main objective of the ER diagram, when considering about the ER diagram and the database, main objective is to minimize the data redundancy. So you can see this, the data, there are so many duplicate values, then there are so many redundancy occur within these two tables. So we need to convert this M2N, that means many-to-many relationship, into one-to-many relationship. Okay, to convert this one, they introduce another entity known as a composite entity or a bridge entity. You can see this is the ER diagram for this scenario. A student takes the class. This relationship is many to many. So we map this ER diagram into two tables. At that time, you can see there are so many duplication values. That means maximize data redundancy of the within these two tables. So we are going to minimize this redundancy by converting or by decomposing this end-to-end relationship into one-to-many relationship. That means many-to-many relationship into one-to-many relationship. To decompose this end-to-end, that means many-to-many relationship into one-to-many relationship, you need another entity as a composite entity. Okay, so the composite entity, by using this composite entity, we can decompose many-to-many relationship into one-to-many relationship. You can see the composite entity is enroll. I think in last week or last session we were discussed about composite entity. So composite entity can be denoted by using a diamond shape within a rectangle. So you can indicate enroll as the composite entity of this relationship. I think it is most suitable to take it as enrollment in a noun form. No issue, you can use both verb. You can use enroll or enrollment as the entity name. So you can convert this one. This student take class as a student enroll or enrollment into the class. This is the composite attribute. Okay. And when considering about this relationship, student can enroll into many classes. So when we consider about one class has many students. So this side is one to many, and also again this side is many to one. So you can see many to many relationship is decomposed into two one to many relationships. Okay. You can see this is the ER diagram. So now we are going to create a table, that means relational schema or a table for these three entities. You can see there are three entities. This is the composite entity. So this entity acts as an entity as well as a relationship. So this is the composite entity. You can map this entity. You can map a table to this entity also. You can see these are the three tables. The first one is student, and the next one is class, and this one is enroll or enrollment. So can you all hear me clearly?
No, madam. Sometimes it's not very clear.
My internet connection is unstable today. This is not the sound. Yeah, this is due to internet connection. I think it is not stable today. So sorry for that. Let's try to continue. Okay. Now, is it clear now?
Now clear, madam.
Okay. Then you can see now we are going to map this ER diagram into table schema. You can, that means relational schema. You can see this one. Student table can be mapped like this: student number and the student last name. This is the primary key of this table. Then this one, class, we can map the class table. So this is the class table. So when we consider about class table, class code is the primary key. This is the primary key, and you can use, when consider about this one, this is one to many. This is one to many. Let's take this one as a student ID. In this case, class ID as the primary key. Okay. Then this class code is the primary key, and the course code is the foreign key. This is the foreign key. Then when we consider about enrollment, this is the connection between these two tables. So the enrollment table is consist with class code and the student number and the enrollment grade. Okay, you can see this is when consider about this. This is one to many. No, there is a rule for one to many relationship. What is it? When mapping ER diagram into a table, there is a rule for foreign key and the primary key of these relationships. What is that? What is the rule? I already discussed about this one. When consider about one to many, when mapping this one to many relationships into a table. So what is the primary key of this table? There is a rule as it is needed to indicate the primary key of one side as the foreign key of in many side. Primary key of one side needed to map as a foreign key of many side. It is a rule. Okay. Okay. Is it clear? ඒ කියන්නේ දැන් අපි M2M කියන්නේ many to many one to many relationship එකක් map කරද්දි one side එකේ තියෙන primary key එක අපි අනිවාර්යයෙන් many side එකේ foreign key එක කරලා map කරන්න ඕනේ table එක map කරද්දි. Is it clear?
Yes.
Okay. So you can see this one. So when we consider about class code, it is the primary key of in the relationship type one to many. When consider about this one to many. Okay. So in one side, this is the primary key. In course code, class code is the primary key. So when we consider about enrollment or enroll table, you need to indicate class code and the student number, and these are the foreign key, or the not these two act as a foreign key as well as the primary key, because no other values to be considered as a primary key. No, these are unique. No, so you can take these two as a primary key, and it is needed to indicate foreign key of these two table in this table. Is it clear? One to many relationship, the primary key of one side act as the foreign key of many side. Or it is needed to indicate primary key of this side in this side. Is it clear?
Yes, madam.
Okay. Now I'm going to clear this one. Let's take another one like this. This is A, this is B, and this is C. Okay, there are three attributes. K is the primary key. Then there are some other attributes like B, then the C. In this case, D is the attributes in this relationship. In this case, simple C is the primary key. Then K, not K. Let's take another W and F. Okay, now we are going to map or convert this into a relation schema. So what are the tables? Identify the tables. These are the three attributes. These are the three entities, and these are the attributes. So what are the tables?
B, A, and C.
B, A, and C. What is the primary key of B table?
A.
Okay. What is the primary key of C?
C.
Are there any primary key in the B? Sorry, but not primary key. Foreign key in this table?
No.
In this table?
Has to have
C.
Sorry?
C.
C is the primary.
C, madam.
C is the primary key. Okay. Then let's consider about A. It is a composite attribute. So what are the primary keys of this table? This one-to-many relationship. This is also one-to-many relationship. So what are the attributes and the primary key? So tell me, what are the attributes available in this table?
A.
A.
can see.
Other than A, what are the other attributes? So this is in many side.
C and K.
K and C. So these two can be act as a primary key and foreign key. Okay. Is it clear now?
Yes, ma'am.
This is main side. So it is needed to insert primary key of this side and this side into this attribute when mapping into a table. Okay. Okay. Then let's discuss about now we are discuss about one-to-one relationship as well as one-to-many relationship and many-to-many relationship, how we can convert ER diagram into tables. So you can see this is the expanded interrelational model. We illustrate one-to-many relationship between course and the class in this diagram. Then you can see this is the relationship student enroll class and class has course. This about one-to-many. All these relations are one-to-many. Okay. In one-to-one relationship, we directly map this into a tables. When consider about one-to-many, we indicate primary key of one side into foreign key as the many side. Then you can map this into a relational scheme. I'm going to mute you all first. You can create a relational schema for this ER diagram. So you can see there are 1, 2, 3, 3 entities as a student. Then this is a composite entity. There are 4 entities: student, enroll, class, and the course. When we consider about relationship type, you can see one-to-many, one-to-many, one-to-many like this. So you can create a relational schema by using Microsoft Access like this. Is it clear? We already discussed about 3 types of relationship: one-to-one, one-to-many, and many-to-many relationship. We cannot directly map many-to-many relationship into a table. At that time, we decomposed many-to-many relationship into one-to-many relationship. After that, we can represent those entities in a table. Is it clear? Before moving to other part, is it clear?
Yes, madam.
Okay, then let's discuss about relational database model part 2. So this is about relational data model. Then let's discuss about conceptual model. In this conceptual model, so main idea is to identify the main data object. So mostly we use ER diagram to model the conceptual model, or we are using ER diagram in this conceptual model. And you can see database blueprint is also a conceptual schema. So the conceptual schema, we visual represent of the entities and the relationship type. So we use ER diagram as an example. Let's take XYZ university. In conceptual model, mostly we use ER diagram to represent the conceptual model. Now we are going to discuss about this ER diagram. In ER diagram, you need to create a ER diagram according to the scenario. So let's take XYZ university as our data. That means scenario. When consider about XYZ university, you can see there are so many data objects as students, professors, courses, classes, and the classroom. So you can see these are the entities available in XYZ university. When considering about XYZ university, you can see these are the data objects: student, professor, course, class, and the room. Okay, so it is when you are creating an ER diagram, so you need to have some idea about entities and how you can identify the entities. As an example, let's take a bank scenario. Can you identify the entities available in the bank? Just try it. No need a complete answer, but try to identify the data objects available in a bank. So what are the entities available in the bank? So when you are creating a ER diagram for bank, what are the entities that you use? Sorry?
Employee.
Employees. Then what are the other entities?
Tutors.
Sorry?
Customer.
Customers. Then
Counters.
accounts.
Bank number.
Bank number is an attribute to that. I'm talking about entities. That means accounts. Bank number belongs for accounts. No, then the account is also a entity in the bank. Then give me some other entities. Okay, in bank scenario.
Manager.
Yeah, manager. Manager is also belongs to a employee category, but manager doing somewhat differ from this. So the manager, then the employee, then the accounts, and what are the other things? Customer. And you can take loan. No, loan is also entity, no? You can take loans. Likewise, you can define some entities available in bank scenario. So in your exam, you have an ability to identify the entities available in given paragraph for a given scenario. Okay. So in XYZ university, these are the entities: student, professor, course, class, and the room. So when we consider about the student number, NIC, then the first name, last name, and the middle names are attributes of this student. So course, give me some example for the attributes of the course. What are the
Course code.
Yeah, course code. Then other attributes.
Course ID.
Course ID, that is course name, course ID. Then
Course description.
Credits.
description. Visa can be taken.
Course period.
Course payment.
Course payment. Yeah, that is very important. Course payment. Then course credit.
Course duration.
Course duration. Course credit. Number of credit offer for the course. Likewise, you can take many attributes for course entity. Okay. Then, so I think now you have some idea about how to identify the entities in a given scenario. Then let's discuss about relationships available with these entities. Okay. Definitely relationship can be a one-to-one, then one-to-many, and many-to-many. You can see this is the complete ER diagram or a conceptual schema for XYZ university. Okay, this is a complete ER diagram for XYZ University. In our next lecture, we are going to discuss about how to draw a ER diagram. So you can see this is a conceptual schema. The professor teach class. This is the relationship time. This is one-to-many relationship. Can you see any many-to-many? Yeah, this one. So this is many-to-many relationship, and converting this into a normal, that means a relational schema, we need to decompose this M2N relationship into one-to-many relationship. So this is the ER diagram. Okay, this about no need to put your student numbers and your student name into the chat. Okay, so you can see professor then teach class. So one professor can teach for many class. When we consider about one class, it is definitely belongs for one professor. Likewise, you can create the relationship between relationship and the relationship type between the entities. Okay, now let's go to this one. As an example, let's take professor. Professor may teach many class, but each class is taught by only one professor. So that there is a 1-to-m relationship between professor and a class. Then let's take course. Course generate classes. This one, course generate class. When consider about this relationship, each class refers to a single course. Definitely, this class belongs to database implementation, database designing and implementation. So one class belongs to one course. So when we consider about one course, it can have many classes. So this relationship also a one-to-many relationship. Then let's discuss about class requires room relationship. This one, class requires room. When we consider about this one, it is also one-to-many relationship. There is one-to-many relationship between room and a class. Class may be scheduled for, classroom may be scheduled for many classes. So the class and the room, the class and the room. When we consider about one class, it is required many room. When we consider about one room, it is belongs for, in this case, one class for one room. When consider about the one class, it may contain one room. When consider about one room, it can be used for many class. The relationship is one-to-many. Then the next one is class may contain many student relationship. That means this one. When consider about class, one class can have many students. When we consider about one student, definitely he or she belongs for many classes. So this relationship is equal to many-to-many relationship. Okay. Then so when consider about these conceptual models, model gives some very important advantages. So the first one is it forms the basis for the conceptual schema, which provide the relatively easily understand the bird's eye view of data environment. So when we consider about the conceptual model, we can easily identify the entities as well as the relationship. So it is a advantage in this conceptual model. And also you can see the second advantage is this is independent of both software and hardware. When we consider about the conceptual model, definitely we use ER diagram to represent the conceptual model. So this ER diagram or a conceptual model is independent from both software as well as hardware. Okay, so when as example, when after create this ER diagram, we convert this into a database. So this is not depend on software as well as hardware. That's why we called it as an independent from both software and the hardware. Then let's discuss about the internal model and the external model of the conceptual data model. So when we consider about this internal model, internal model requires the designer to match the conceptual model's characteristics and the constraints to those of the selected implementation database model. So when you are creating a database model, the database designer has responsibility to identify the requirement as well as he or she has responsible for implementing a ER diagram for ER diagram in conceptual model. So when creating your ER diagram or when creating your conceptual model, it is needed to accept the characteristics and the constraints available in the conceptual model. Okay, so this internal model depends on the existing of a specific database software. So when you are creating ER diagram, that means you are creating not you are representing or creating this ER model, you need to have some software. So this ER model needed to follow the characteristics and constraint available in that software. So when consider about internal model, it is definitely depend on the software. So internal model is depend on software but does not depend on the hardware. Therefore, the change in the DBMS software requires that the internal model be changed to fit the characteristics and the requirements of database management system. As an example, you are going to create a database management system by using software 1. It is totally different from when using software 2. Likewise, so when creating the internal model, you need to change or fit your ER diagram according to the characteristics and the requirements of the DBMS. You can see we implement the internal model by creating the database for XYZ university using the table professor, course, class, student, and the row. And we must create the composite entity between class and the student. We will make this composite entity as enroll. So when you are modeling this ER diagram by using your database management system software, you need to convert this M2N relationship into one-to-many relationship. That is a constraint or a characteristics defined by DBMS. Okay. Then about this is only depend on only depend on software, still hardware independence. Okay. Then when consider about external model always define the end user's view of the data environment. So when we consider about data environment, this external model defines the end user's view of this data environment. Okay. By the end of the user, we mean the people who use the application program as well as those who design and implement them. The external model is depend on the view of end user view. When we consider about end user can be a customer. That means end user can be a people who use the software or people who design the software. Okay, so this is differ from person to person. This external model is differ from person to person because it is depend on the end user's view of the data environment. So you can see this is external schema. This is about programmer Smith view. This is about programmer Shamila view. By considering about different type of users, this external schema is differ from one user to another user. Okay. No need to go through this one. This is the external model. According to these two waves, you can see this can be taken as a student registration process, this M2M relationship. This one can be taken as a class scheduling. This is about class scheduling. No? So this can be taken as a class scheduling. This can be student registration. Likewise, we can change the external view of this model according to the end user viewpoint. Okay, so I think that is enough for this session. Then let's move into ER diagram. So you need to get some basic idea about what is the relationship model and the ER diagram. So in relational schema, we use data tables and their relationships. But in conceptual model, we use ER diagram to denote this conceptual model. Then let's discuss about how to develop an ER diagram for a given scenario. Okay. Before that, do you have any questions? No need to go through all the description. These all are available in your book. Do you have any questions before moving to ER diagram? In your exam, first CAT exam, definitely it's a ER diagram and the relational schema. Before moving to the ER diagram developing, do you have any questions? Can you all hear me clearly?
Yes, ma'am.
Yes, ma'am.
Do you have any questions? If not, we can continue. Think no question. Then let's discuss about ER diagram. So in this lesson, we are going to discuss about developing an ER diagram. So when consider about the process of database design, it is definitely iterative rather than a linear or a sequential process. The iterative means one based on the repetition process. That means iterative means repetition. As an example, you can take a building an ER diagram for a certain company, and it is begin with the general narratives and of the organization operations and the procedure. But the next basic ER model, it is graphically represent, and you can present it in for review. At the first step, you can take a basic operation and the procedure available within the company, and you can create a ER diagram, or you can map that requirements into a ER diagram, and you can present it for the review. So during the review process, it is like that additional object attributes relationship will be uncovered. You can see. Can you all hear me?
Yes, madam.
Okay. So okay. Please give me 1 second. Can you all hear me?
Yes, ma'am.
Okay, there are some issues in internet connection. Wait. Okay, so when you are in, now we are in review process. So in this review process, the review person suggests some additional objects, attributes, relationships that will not be covered in your ER diagram. So you need to modify your ER diagram according to the reviewer's comment. Okay. Likewise, you can see there are so many. Subsequently, another round of review may need additional components or a clarification of the existing diagram. Like this, you can see this process is repeat until the end user and the designer agree to the same ER diagram. Okay, so when it comes about developing an ER diagram, first you gather the requirement and you develop a ER diagram, then you present it into a review. Reviewers review your ER diagram, and they can sometimes they add some additional comments on your ER diagram. They add some additional attributes as well as additional relationship and the additional entities into your ER diagram. Then again, you are going to modify this ER diagram according to their requirements. Again, you present it into the reviewers. Then again, they can have some comments for your ER diagram. Likewise, this process is going until the end user and the designer agree to the same ER diagram. Is it clear? So this developing an ER diagram is a repetitive, that means iterative process. Is it clear? දැන් ER diagram එකක් develop කරද්දී ඔයාලට පේනවා ඉස්සෙල්ලම company එකට යනවා user requirements ගන්නවා ඔයාලා ER diagram එකක් මේව කරනවා then the reviewers ලා අපි තුන් company අයිති එක්කෙනාට දෙනවා හරිද කියලා බලන්න. එයා කියනවා නෑ නෑ මේක වැරදි මේක add වෙන්න ඕන. ආයි ඔයා ER diagram එක develop කරනවා. ආයි review එකට present කරනවා. සමහර වෙලාවට එයා සමහර attribute වෙනස් කරනවා. ඔහොම කරලා එක වෙලාවක් එනවා ඔයායි review එහෙම නැත්නම් company අයිති කරයයි එකම එක ER diagram එකට කැමති වෙන. අන්න එතකන් ඔයාලගේ මේ ER diagram එක develop කරන process එක යනවා. So it is a iterative process. Is it clear? I already explained in both English and Sinhala. Is it clear? No one in the class? Is it clear?
Yes, madam.
Okay.
Yes, sir.
Okay.
Yes, madam.
So when considering about ER developing process, database designer does not simply depends on the interview. Sometimes, most probably they arrange some interviews and that means they meet designer. Now I'm going to talk about the designer. So when the designer design an ER diagram for a given scenario or a given company, this designer use different techniques to gather the information. Okay, so sometimes they use interview method as well as they use some documents and the procedure available in the company. Likewise, they use different data collection method to collect the data to create the ER diagram. Madam, can you speak little bit slow? Okay. Then you can see. You can see the database designer does not simply depends on the interviews to help the define entities, attributes, and the relationship. A surprising amount of information can be gathered by examining the business forms and the reports that the organization uses in their daily operation. So you can use interview methods, then the questionnaires method, as well as forms and the reports about their organization daily operations. By using all these things, you can collect or you can gather the information about the company. By using that information, you can easily identify the entities as well as the attributes and the relationships between the attributes. Then, to illustrate the use of the iterative process that ultimately is workable ER diagram, suppose we start with an initial interview with XYZ university administrators. The interview process is a basic description of the university activities. So when this is about XYZ university. So now we are going to discuss about how to create a ER diagram. So our main objective is to create a database for XYZ university. To create a database, it is needed to have a ER diagram, because we are going to we are going to convert this ER diagram into a database. So it is needed to create a ER diagram first. To create the ER diagram, it is needed to identify the relationship, entities, and the attributes within this organization. So now we are going to discuss about XYZ university. So to create this ER diagram for XYZ university, we are going to discuss with the university administrators. Okay, so this is the first case identified by discussing with. Can you all hear me? This is very important. That's why I am asking like this.
Yes, madam. Yes, madam.
Okay, now we are going to create the ER diagram, that means database for XYZ university. First, we are going to meet the XYZ university administrative, and we conduct a interview with them. So these are the facts gathered, or the requirements gathered by interview. That means these are the information gathered by a interview, okay, with the university administrators. So the first case is this XYZ university is divided into several faculties. So when we consider about XYZ university, it is divided into several faculty: a faculty of business, the faculty of art and science, and the faculty of education, and the faculty of applied science. So the university is there are 4 faculties. So each faculty is administered by a dean. You can see each faculty is administered by a dean. Note that the cardinality can be expressed by 1:1 for the entity dean and by 1:1 for the entity faculty. So the smallest number of the dean per faculty is 1, as is the largest number, and each dean is assigned only the 1 faculty. Therefore, the relationship between this dean and the faculty is equal to 1:1. Okay, so this is the first case. I think it is clear when I'm editing this one in Microsoft Edit. Okay, this is the first case. You can see okay. Okay, now we are going to create a database for, ER diagram for XYZ university. First, we identify 2 entities. So what are the entities available in this scenario? Identify the entities. What are the entities?
Professor.
Professor is not in this scenario.
Faculties.
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 The faculties are the 2 entities available in this scenario. The relationship between the faculty and the dean is equal to 1:1. Okay. Then there are There are several ways to evaluate the relationship between this dean and the faculty. Each dean is a member of large group known as the administrator. So when we consider about a dean can be a belongs to the group of administrator. Definitely, dean is the person who do the administrative things in your faculty. So this dean can be grouped as a administrators. So we may include the deans is an administrator entity. So the dean and the faculty, then the administrator entity. So there are three entities. I'm going to underline the entities in this scenario. You can use a pencil or a pen to underline the entities when you are reading the paragraph. So I think it is best practice. When creating a ER diagram, you can use a pencil and you can underline the entities. So these are the entities. Then administrator. Then dean also hold the provisional rank and may teach a class. Therefore, dean may also include within the professor category. So dean can be a professor. So you can see professor is also an entity in this scenario. In addition, administrators and the professors, there are some other employees. So when we consider about a faculty, there are some professors and the administrators. Apart from these two, you can see there's so many employees. So employees also a entity in this scenario. The depending on the information requirements and the database designer's view of the requirement, it might be useful to evaluate the feasibility of creating a super and subtypes relationship for this scenario. You can see employee. When we consider about employees can be administrators as well as professors. Apart from this, there are some other employees. So employees can be professor or a administrator. The administrator is the dean of the faculty and professor teach the class. So these are the things available in this paragraph. Okay, so I already create a small rough diagram for this paragraph. So you can see employees can be a professor or administrator or other employee. And when we consider about a professor group, professor teach the class. And when we consider about administrator is a dean of the faculty. So this is the super and super type relationship for this scenario. Okay, then always keep in mind the good database design requires the designer to consider the information requirements and the organization business rules. So when after identified these entities, you need to discuss about the information or requirements of the organization. So in the XYZ University's operational environment, the professional characteristics, academic degrees, academic rank of the administrators and the professors are identical. So when we consider about administrator and the professors, all these attributes available for these two entities are identical. That means all these are same. So because none of the employees are required to have such academic attributes, their relevant subtype is reduced to professor and the employees. Okay, then most DBMS do not support the subtype relationship directly. Design converted into one-to-one relationship as shown in the following ER diagram. So when we consider about professor, he is an employee of the company of XYZ University. So you can represent this scenario by using a ER diagram like this. professor is an employee. So in this case, this is a super type subtype. So we can create a most probably the super type subtypes are not available with the DBMS software. So you can see this employee when consider about all the that means all the attributes of these two entities. These two entities are identically equal. So that's why we create like this. Professor is an employee. Okay, you can take when you consider about these two, professor is a employee. We can create a entity like a relationship like professor is an employee. So the professor is an employee. In this case, not all the employees are professors. So the professors are optional to employ. In other words, an employee is required to professor. You can see when consider about this dean as the administrator, no? So you can see this relationship. We can build a relationship between the employees and the professor. Employee is an professor. That means professor is an employee. When we consider about this side, professor is an employee one-to-one. When we consider about employee, that employee not the cannot. That means in all the case, not all the employees are professors. So 0 to 1. So the relationship is 1 to 1. So this is not a mandatory. That means not all the employees are professors. No. So this is not a mandatory relation. That means this is not a mandatory. So we can use optional sign for professor entity. Okay. So when we consider about all the relationship between this all the relationships in this scenario, you can see employee is an professor, then professor is a dean of the faculty. There are two relationships now. When we consider about a professor, professor is an employee as well as professor is a dean of a faculty according to their requirements. Okay. So you can see this is first case. Now I'm going to create this in. Okay, let's take employee. This is the employee attribute. When we consider about employee attribute, employee, let's take professor is an employee. This is not compulsory, so you can indicate the mandatory sign. Relationship is equal to 1 to 1. No need to 1 to 1. Then when we consider about the faculty and the professor, professor is the dean of the faculty according to this scenario. Professor is dean of faculty. When consider about this one, this relationship is equal to 1 to 1. When consider about one faculty, it is definitely have only one dean. When one dean is holding a deanship for one faculty. Okay. Then let's move into our second scenario.
Yes, madam.
Okay. Go ahead.
There's a phrase there, and in other words, an employee is required to be a professor. Is it true?
Which one?
An employee is required to be here.
In this one?
No,
This one? In which slide?
yes, in other words,
In other
words, an employee is required to be a professor. It is true? No,
no. Which one?
it is not required to be.
Not required to be a professor. That's why it's indicated as this. This is not mandatory.
Yes.
In which slide? or
No,
a,
it is this one.
this one, yeah, this one.
No, no, no.
In this,
Excuse me, madam. Up, madam.
sorry.
Yeah, here.
Yeah,
Here.
18,
Yes.
Is the one.
18.2. Please,
An
18
employee.
point.
In other words, yes, here. In other words, an employee is required to be a professor. It is not
So
required.
this is, yeah,
Yes.
this is wrong. This is a mistake. In other words, the employee is not required to be a professor. This is all.
Yes.
So
Yes. Thank you. Thank you, madam.
really, this is wrong. Okay, then let's discuss about second scenario. Each faculty is composed of several departments. So the second scenario, the second case identified by the interview is the faculty is composed of several departments. So the faculty of the business has accounting departments and the marketing departments and economics, finance. Likewise, there are so many departments available in one faculty. So you can see again this one. Faculty operates department relationship. So when we consider about faculty can be consist with many departments. So according to this scenario, they indicate that on the other hand, each department belongs to only a single faculty. This is the requirement of the XYZ. Thus, the cardinality expressed by 1 to 1, that is the minimum number of faculties that a department belong is 1 and the maximum number as the maximum number. So you can see the relationship between faculty and faculty operates department. When we consider about one faculty can be have many department. What when we consider about one department, it is definitely belongs to one faculty. The relationship between these two is 1 to many. Again, I'm going to take this one. Faculty operates departments. One faculty operates many departments. So one department is belongs to one faculty. Okay. You can see one faculty operate many departments. When we consider about one department, it is belongs to one faculty. So you can change the cardinality as 1 to many. Okay. Then the third scenario, each department offers a several course. When we consider about a department, this department offer different type of courses. That means each department offers several courses. So you can see department and the courses. This is the relationship. When consider about one department, it is of many courses. But when we consider about one course, it is definitely offered by one department. You can change the cardinality. The maximum is 1, then the maximum is many. So this relationship is 1 to many relationship. So the department and the course, this department, department offers course is an entity, then one department offer many course. Okay. Then let's move into our fourth scenario. We illustrate the relationship between course and the class. It is worth repeating. A class is the section of a course. Now we are going to discuss about the relationship between course and the class. So the department may offer several classes on the same database course. As example, when you consider about database, you can see there are 4 or 5 classes or a day school for your database course. So one course offer many classes. In short, the exist one to many relationship between one course and the class. However, because the course may exist in XYZ university course catalog, even when it is not offered a class in a current class schedule. So the class is optional to course. So according to the XYZ administrator, and that means XYZ university requirement, so no need to have classes for some courses. So you can take course generate class relationship when we consider about one to many. One course can, when we consider about this one, let's take classes. So when we consider about one class, it is definitely belongs to one course. But when we consider about a course, it can be have class, so it cannot have any class. So the minimum is 0, maximum number is equal to many. So many to 0 to many, this 1 to 1. So you can change the cardinality. So the maximum is 1, this side maximum is n. So this relationship is 1 to many. Is it clear? According to their requirements, some courses.
Yes, ma'am.
Okay. No need to offer any classes. So the minimum number is 0, the maximum number is many. In this case, definitely classes belong to a course. This one is the minimum and the one is the maximum. You can change the cardinality 1 to many. So I'm going to represent this is also course. Course generate class. Course generate then classes. Okay, this is the next scenario. Then let's move into fifth case. Each department has many professors assigned to it. One of those professors chair the department. When we consider about the department, definitely it has a department head. No? So when you are consider about the relationship between the professor and the department, one professor chairs the department. So the professor chairs. You can take this one of these, that means when we consider about this one, only one professor chairs the department. Only one of the professors can chair the department to the which he or she is assigned, and no professor is required to accept the chair position. Therefore, the department is optional to the professor in the chair's relationship. So each professor is assigned only for one department. Each department has at least one professor assigned to it. So the relationship are summarized like this. Professor chairs the department, or professor is assigned to a department. The relationship is, there are two cases. The first case is, madam, in the diagram, why we use a circle before the entity? If the entity is optional entity, you can use circle. If the mandatory, no need to indicate it. If the entity is optional one, you can indicate it by using a circle. So in this relationship, that means the relationship between professor let's take this one. Professor and chairs the department. When we consider about a professor, one professor chairs one department. So the relationship is equal to 1-to-1 relationship. Then when consider about department and the professor relationship, you can see department is assigned to professor. That means when consider about the relationship between the professor and the department, you can see there are so many professors in one department. So the relationship between the department and the professor is equal to 1-to-many. There are two relationships. The first one is professor chairs the department. One professor definitely chairs the department. So 1-to-1 relationship. So it is not no needed to become, that means this one. No professor is required to accept the chair position. That's why we take it as an optional. Then let's take the professor and the department. There is another relationship between this department and the professor. You can see it when we consider about a department, it is consists with professors. So one department consists with many professors. So this is indicated by this relationship. Okay, there are two relationships. You can map these two relationships. So it is, yes, the professor chairs, then this is the chairs. You can see this is the department. So you need to connect these two. One professor chairs, one department. And you can see there is another relationship. Professor is assigned to department, one department, many professors. Likewise, you can create a ER diagram. So it is impossible to create a ER diagram in this small area. Then let's discuss about sixth scenario. In this scenario, each professor may teach up 4 classes, and the professor may also be on a research contract or teach no classes at all. Sometimes professor can teach the class, or sometimes he or she can be engaged with only a research activities. So each class is taught by only one professor. So let's discuss about the relationship between professor teaches the class. So one professor teach, one professor. When we consider about a class can be, one class can be taught by one professor. But when we consider about professor can teach many classes, and also the minimum number is equal to 0, because professor cannot do any, that means professor do not engage with teaching activities. He or she only engage with research activity. At that time professor does not teach any classes. So the minimum number is equal to 0. You can change the coordinate. Maximum 1 is many, maximum 1 is 1. So the relationship is equal to 1 to many. Then let's move into next. Before that, I'm going to draw this one. Which one? This professor teach classes. Are there any? This is class, no? Professor. This is the professor, no? Professor, no, don't. Yeah. You can take this one like this. Professor, then teach class. It is impossible to draw in this notebook. Professor teach class, one professor teach many class. Okay. Then let's discuss about our next scenario. It is about enrollment of the students. So that during the current enrollment period, a student may decide to take 5 classes as statistic, accounting, English, and the database and history. Each student may enroll in up to 5 classes, and each class may have up to 35 students in it, thus creating an in relationship between the student and the class. You can see student enroll into the class. You can see when consider about the relationship between student enroll into classes, one student can enroll into many classes. When we consider about class, it can be, when consider about class is consist with many students. So this relationship is one to many, many to many relationship. Because the classes initially exist, even though the no students have enrolled in it, student is optional to a class. So when we consider about a class, student is optional. In sometimes there are some courses that do not have any, that does not have any students. So this student is, sorry, this Yeah, student is optional to class. When we consider about a class, student is optional. So you can see M2M relationship. We need to decompose this M2N relationship into one-to-many relationship. We use composite attribute to decompose class, decomposed into class, enroll decomposed into the enroll entity, composite entity like this. But when we consider about class, student is not necessary. So you can create optional scenario by using a circle. Then when we consider about a student and the enrollment, one student enroll for many classes. So when we consider about one class, many students are enrolled. So the relationship is one to many. Okay. Then I'm not going to draw it in this. It is difficult to draw. Then each department has several students whose major is offered by the department. So to be classified as a department, the student must has at least one student. So let's discuss about department and the student. So relationship between the department and student. Department has student. When we consider about one department, definitely it is consist with many students. So this is a simple case. Relationship between department and student is equal to one to many. Then the last one, each student must have only one advisor or his or her department. That means professors are the person who advise the student. That means counsel the students. The professor advise the student. The relationship between the professor and the student is equal to one to many. When we consider about one professor, this professor advises for many students. But when we consider about one student, this students definitely counseled by one professor. The relationship is equal to one to many relationship. But when we consider about this relationship, when we consider about the relationship, but not all the professors advise the students. So when we consider about the university, all the professors are not assigned as the advisors. So you can see when consider about the professor, this student is in this relationship is student is optional, because every professor does not have a student. So this is a optional entity. So you can denote optional entity by using a small circle in this side. Okay, now you can see we already discussed about 9 scenarios. According to the 9 scenarios, these are the entities, relationships, and the connectivities. So the first one is faculty. Faculty operates the department one-to-m relationship. Then department has student one-to-many relationship. The next one is department of one-to-many. That means offer courses one-to-many. Then the course generates the classes one-to-many relationship. When consider about the professor, professor is an employee one-to-one. Professor is a dean of the faculty one-to-one. Professor chairs a department one-to-one. You can omit this one if you need this one. Then professor advise students one-to-many relationship. No, this is not omitted. Professor is an assigned to a department many-to-one relationship. Student enrolls in many-to-many relationship. We convert this into one-to-many relationship by decomposing this many-to-many relationship. So this is the final complete ER diagram for all above scenarios. Okay. This is half. There are some missing cases in this ER diagram because no space to draw that scenario. So this is the final one. All the discussed scenarios are available in this ER diagram. So this is the complete XYZ University ER diagram. Is it clear? Is it clear?
Yes, ma'am.
What about others?
Yes, madam. Yes, madam.
Yes.
In your CAT exam, I'm planning to give a scenario like this. At that time, you have to create a ER diagram for that scenario. Is it possible now?
Yes, madam.
Okay. Mm. So in sometimes you can see, not according to your book, most probably some ER diagrams indicate the attributes as well. In this ER diagram, you can see only the attributes relationship types. So in some ER diagrams, it's indicate the attributes also like this. Employee ID, this is the primary key, and these are the other attributes. Likewise, you can see in some ER diagrams attributes are also represented, but in your syllabus I think I'm not sure about in your syllabus, it is not necessary to indicate the attributes, but the but we expect this kind of ER diagram. Okay. Yeah. Sometimes it can be some question like what are give an example for the primary key in the employee entity or any other thing. Or what are the foreign keys in professor chair's department relationship? Likewise, we can ask other question by using the ER diagram. It's due to internet connection. This is for Fernando, I think. It's due to the internet connection, not a stable connection. Today the connection is not yet stable. That's why I think my sound is not clear. Before moving to next part, is it clear or there are any doubts? Okay. Can you all see this Word document? Can you all wait? Can you see this one? Can you see this one?
Yes, ma'am. Word document.
Okay, now I'm going to give you a small break. In this break, you can, this is a small one.
Madam, can't hear your voice clearly.
It's due to a internet connection. I think today's connection is unstable. That's why I'm planning to upload video. So that means recording to your Learno USL. You can refer that also. At that time, you can handle the situation. Okay, let's take a small break. Hello, can you hear me?
Hello? Yes,
Yes, ma'am.
madam. Yes, madam.
Let's take a small break, 15-minute break.
Okay. Okay, madam.
Okay, madam.
Go through this question.
Thank you.
First question. You can go through the first question and identify the attributes and the entities in this database. Let's start again at 3:25. Okay, shall we start now?
Okay, madam.
Okay. You can you all see this question? This one? Can you all see this question? Okay. Just a minute. Okay, this is the question. You can go through this one and identify what are the entities available in this scenario. Can you identify
Seller, product,
seller and the product? What about others? Is it correct?
Yes, madam.
Yes, madam.
Seller and the product. So, what is the relationship between these two entities? Can you define a relationship between these two entities?
Many to many.
Many to many.
Relationship type. I need a relationship name.
Sale.
Say. Some other suggestions. Give other suggestions. Sales is the best one, no? Seller sells the product. Okay, so what are the attributes? You can, let's take this color. So what are the attributes available in the seller entity?
name,
Seller name, contact, email, postal address.
Contact, email, and postal address. Okay. Then for each, so what are the attributes available in the product entity?
name,
Name,
price,
price, number.
number,
Product number, P number.
Product ID.
Sorry. P number, then
ID number,
ID number, name, price, number. Yeah, there are one, two, three. Each for each product. Yeah. Three, then 1, 2, 3. Yeah, okay. There should be a unique number for each. So, what is the relationship type between these two entities?
Many to many.
Wait, every product must have at least one seller. Okay, when we consider about every product, it must have for each seller there should be a unique identity number for each product. By identify. Okay, before that, what are the what can be taken as a primary key of this site?
that ID number,
Number. This one in this site.
Name.
Seller, their name, contact number, postal addresses are recorded. You can take name. So name can be a composite, or you can take first name, then the last name, and the middle name. So you can take these three as primary key of this site. Okay, for each product. So this relationship, what is the relationship type between these two entities? And consider about seller. What is the cardinality? one seller,
One and many.
one and many. Minimum number is one, many. When we consider about product one, what is the cardinality? When consider about book, book can be sold by one person or a many. So the relationship is many to many. So can we keep it like this?
Has to be composed.
Sorry.
Has to be composed into one to many relationship.
Then you need to decompose this relationship. You can use any word. Let's take like selling or anything. Then you can wait. Selling, then product. This is a composite attribute. This is a seller. You can indicate all these attributes for these two. Then when we consider about the relationship one to many, then many to one. Okay. Likewise, you can create ER diagram according to your preference. There are some questions. Do you?
Ma'am, excuse me.
Okay. Go
Yeah, in
ahead.
the diagram,
Hmm?
they have only said about the name. So do we have to subdivide it into first name,
Yes.
last name, and middle name?
You are giving a multi-value attributes as a telephone number, you can guess and you need to indicate it. When consider about the seller,
In
you
the question, they haven't mentioned about it anything. Just they said just a name only.
so this is not true. You can make some assumption. You can assume that name can be a composite attribute. Then you can subdivide. As an example, then take a telephone number. So telephone number can be a multi-valued attribute. Likewise, you can make assumption. So it is needed to indicate this assumption at the end of the ER diagram. I think it is mandatory for your exam. Okay. You can make any assumption. So when we consider about name, it's just a field. Now, if you take this as a primary key, can be Kamal, Kamal. There are so many names as Kamal. So you cannot take this as a primary key. When we consider about surname, last name, and this one, you can take it as a primary key. Okay. At that time, you can take assumption. This name can be subdivided into this one, and this is a composite attribute. Likewise. Okay. Okay. I'm not going to discuss. When we consider about, yeah, definitely you can take, in this case, the available email number. Yeah, you can use this email number. When without considering this one, you can use email number because you know no, there are no any duplicate email addresses now. So you can use email address. One person email address is definitely differ from other person. So you can use email address as the primary key of this site. Okay. Yeah, contact email. No? You can use that one. Okay. Then there are some other questions. So you can go through this question. Do you need these questions in your learn or use it? It is needed
Yes,
to.
ma'am.
Yeah. Okay. So I'm going to upload this one. You can go through the ER diagram, sorry, this scenario, and you can draw a ER diagram and you can get familiar with ER diagram. Okay, let's take this scenario. I'm not going to draw a ER diagram, just identify what are the entities available in this scenario. Identify what are the entities.
Cricket and country.
Yeah, cricket and country. Then what are the others? When consider about team, You can go through all the,
Players and team.
sorry,
Players,
players and the,
team.
there are some other, some more entities. What are those?
Players and matches.
Sorry,
Players and matches.
players, matches, then the cricket and the countries and the teams, and also there are some other information about venue used for international games, number of playing attended. Yeah, you can take all these things according to your preference. Yeah, players, then the team, cricket, countries. Those are the entities available with this scenario. You can take a pencil and you can underline the entities. At that time, you can get clear idea about the paragraph. Okay,
Excuse me.
go ahead.
After upload this one in the Learn OSL, can you upload the answer sheet also after two days? So we
After
can check whether it is correct or not.
it is impossible to provide the answer within 2 days. I'm going to upload this one in tomorrow. Then
No, just clarify that.
yeah. English day. I'm going to give 2 or 3 database. I can upload it within next week. Okay.
Okay, ma'am. Thank you.
Before your definitely I will upload the answer for this question before your stat exam. Okay. Most probably next week, 7, 8, 9, 10, 11. No? Okay. I can upload at that time.
Thank you, ma'am.
You can go to this example. Then let's move into our topic again. Now we already discussed about how to create a ER diagram for a given scenario. Now we are going to convert this ER diagram into database. After that, we are going to discuss about the relational schema. So in this case, now we are going to model the ER diagram to we already create a ER diagram. Now we are going to convert this ER diagram into a database. Okay. So the converting an ER model to a set of tables in a database is requires specific rule that governs such a conversion. The application of these rules requires understanding the effect of updates, delete on the table in the database. So in this lesson, we are going to discuss about the rules in detail. So you can see as example. Now we are going to convert ER diagram into database. As an example, let's take this scenario. This is about artist database. So this ER diagram is about artist. So we are going to create a database for this artist. That means artist ER diagram. In this ER diagram, a painter might paint many paintings. To be considered a painter in the artist database, the painter must have painted at least one painting. This business rule decrees that the cardinality is 1 to many in the relationship between painter and the painting. Then painting is painted by one painter. I'm going to create. Let's take this one. Yeah, I'm going to draw this ER diagram. So according to the first scenario, this is a small ER diagram. Don't accept this type of ER diagram for your exam. This is more complex than these examples. Okay. Please give me one second. let's create a ER diagram first. So the relationship between the painter and the painting. Painter, first entity, then the painting, next entity. Okay. So painter might paint many paints, many paintings. To be considered a painter, the artist database, the painter must have painted at least one painting. So when we consider about painting at least one, he can paint many paintings. So when we consider about a one painting, that means one art or painting. One painting is painted by only one person. So when we consider about one painting, it is definitely painted by one person. So you can see this relationship. We can change the cardinality. The maximum one is M. So this side M. The maximum one is 1. So this side is 1. So the relationship between painter paints painting is 1 to many. Okay. This is according to this scenario. Then the painting might or might not be exhibited in gallery. When consider about painting, this painting can be exhibited or cannot, that means might be exhibited or not, might not be exhibited in the gallery. That the gallery is an optional entity to the painting entity. So when we consider about the next one, it is about painting and the gallery. So painting is placed in gallery. So when we consider about the painting, you can see this is an optional entity. The gallery is an optional entity to the painting entity. So you can take this is a optional entity. If this is an optional entity, you can denote it by using a circle. Then one painting can be exhibited only in one gallery. So when we consider about one painting, it can only exhibit in one gallery. Then painting cannot, that means painting is not placed in, it can be occur. So 0 is the answer for minimum. That means painting cannot accept, that means painting does not placed in a gallery. Then the next one is, sorry. Then the next one is to be classified as a gallery need at least one painting. So when we consider about a gallery can have one painting or more than one. Then the relationship between these two is equal to many to one. Okay, is it clear? Is it clear?
Yes.
Okay. Then give the description to create the ER model for the matching table. So you can see the painting number. I'm going to indicate painting number. Painting number, then so it is difficult to write all these attributes. You can see these are the attributes available in the painter. Then these are the attributes available in the gallery, and this is the painting. Painter number, then the painter last name, first name, and the painter area code and the painter phone number. When we consider about gallery, gallery number, gallery owner, gallery area code, then the gallery phone number and the gallery record. Then the painting, painting number, painting title, painting price, painting number and the gallery number. So this is the ER diagram. We already create a ER diagram. Now we are going to convert this into a database. So when we consider about these two entities, you can see one-to-many relationship. You can take two tables as a painter and the painting. So paint number is a primary key according to this primary key. You can take primary key like this. These are the attributes. So when we consider about painting number is the primary key, but this is in the many side. So you need to include this PTR number as the foreign key of this table. So this is a foreign key. This is the P. This is also P. Then let's discuss about this one. This is also a one-to-many relationship. So when consider about gallery, gallery number, gallery owner, then the gallery area code, these are the attributes. Gallery number is the primary key. So this is the gallery number is the primary key. So it is needed to indicate gallery number primary key as the foreign key in the paint inside. So you can see this, we can include gallery number as a foreign key of this one. So this is referred to this table and this is referred to, wait, this is referred to this table. So this is the database. Is it clear?
Yes, ma'am.
Okay, then you can see we can convert this into a relational schema. According to your book, always relational schema is represented by using a MS Access, but I have a plan to discuss about relational schema in normal way. Let's consider about that also. Okay, now you can see these are the relationships. This is the relationship schema. This is the ER diagram. This is the ER diagram. Then we convert this ER diagram into a database. After that, we convert this one. We convert this database into a relational schema. You can see one-to-many relationship, one-to-many. These are the entities. Then let's discuss about deleting a record from a painter table. So now we are going to delete a record from this painter table. So you can see when consider about 1, 2, 3. This 1, 2, 3 is Dias, Sunil Dias. This is the primary key, but this primary key available in this table as a foreign key. These two records. You can see these two records. Okay, there is a link between this primary key and this foreign key. So when deleting a row from a painter table, the painter table will contain the reference to the painter who knows a long exists, thereby creating a deletion anomaly. So there is a relationship link between these two. If you delete this one, it's trigger a restriction for this because there is a reference to another table. We should it is wise to restrict the ability to delete a row from a table if there is a foreign key in another table. If there is an attribute as a primary key in a table, if we are going to delete this one and it is referred to a foreign key in another table, at that time there is a restriction as a delete restriction. So the restriction means that we can delete the painter from painter table only if there is no foreign key in other table that requires the painter's existence. So as an example, if this is not a primary key, foreign key for any table, we can delete this record. But this is foreign key for this table, no, so we cannot delete this one. So the delete restriction clause requires that we first delete all the rows in this at that time, database trigger a really delete restriction. At this delete restriction is belongs to this deletion, so it indicate it is needed to delete these two values, these three values first. After that, you can delete this record. So if you needed to delete this one, you can delete these three records first. After that, you can delete this record. So you cannot delete this one directly. If you need to delete this one, first you need to delete these three records. After that, you can delete this record. So this is the delete restriction. At that time, this database trigger a delete cascade. That means delete restriction about this scenario. Then adding a row to a painter table. So adding a painter does not cause any problem. You can add any record with the unique painter number to this table. So no issue with it. No issue in an adding a record to a painter table. Then making change in the painter table. So if you need to make this primary key as 1 to 8, that means modify this 1 to 7 into a 1 to 8. So you are unable to do this because this 1 to 7 is make reference to 3 records in this table. At that time, you can change this one, then you can change this one. Again, update restriction or update update cascade occur. So this cascade define the requirement of update cascade. That means all the foreign reference to a primary key are updated when the primary key is changed. Okay, so this is about the update cascade. Then let's discuss about deleting a row from a gallery table. So when consider about gallery table, so this is about this. Now when consider about gallery table, you can see this is the gallery table, gallery name, gallery owner, gallery area code, gallery phone number, gallery rate. So when deleting this one, this is also has a reference to this table. So if you need to delete this one, first you need to, this is not a, there is another case. You can see when deleting this one, you can see then this foreign key. Where's that table? When consider about this one, you can see some null values. Okay, you can see some null values. So this column can contain null values. So if you need to delete this one, you can make these values into null values like 0, 0. After that, you can delete this one. So in this case, you can see this is a primary key and it is needed to, when we consider about this one, this is a mandatory field. When consider about this table, this is a mandatory. So if you need to delete this one, first you need to delete these records and after that you can delete this record from this table. But when we consider about this one, this is not a mandatory field. So this is an optional one. So this is an optional one for this table. You can see some null values. That's why we conclude that this is an optional one. So at that time, you can set this value to 0. After that, you can change this 5 according to your preference. Okay. Adding a record to a gallery table. Adding a new record does not affect for the database because the gallery does not have any dependencies in the other table. The new row will not refer for any foreign key that pointed to the gallery table. So you can insert any values into the gallery table. So when updating the gallery table's primary key, that means change the primary key value in the gallery row requires that all the foreign key making reference to be updated, as well as there must be use an update case. Okay, so in delete case, you can set it to a null values and you can delete. In gallery table, you can add any value to the gallery table because no reference for new values in the gallery table. When we consider about update in case, you can update the primary key at that time. It also trigger a update cascade clause in your database. Okay. There is a question as, madam, please can you explain what are the differences between a mandatory or an optional? Okay, give me 1 second. Let's take this one. Where's that text? Okay. You can see this one. Painting is placed in the gallery. Okay, so the painting is placed in a gallery is not a mandatory. That means painting can be placed in a gallery or painting cannot or does not place in a gallery. So this gallery is not a mandatory entity for the painting. At that time, it is known as a optional entity. I already discussed these things in previous day schools. Okay, as an example, let's take another one. Let's take this one, professor. Professor is a dean. To become a dean, it is not needed to have a professor. Doctor also, doctor, that means doctor or a lecturer can be a professor in a, that means, sorry, doctor or a lecturer can be a dean in the faculty. So the professor is optional for dean entity. Holding a professor, that means name is optional for dean entity. So that's why we indicate it as a optional entity. Okay, you can go through previous recordings. In previous lectures, we already discussed about these things. Okay, then about governing rules. Okay, this is. Then let's discuss about general rules governing relationships among the tables. So you can see when consider about the artist database, let us next formulate the general set of rules helps to create any database table structures that will meet the required integrity constraint. In this case, we discussed only about the scenarios which is available in the artist database. Now let's discuss about common required integrity constraint. So in the database, all the primary key must be defined as not null. So you can see the primary key cannot be null. No duplication values as well as no null values. Okay, this is the first important integrity constraint available in the database. Then the next one is, define all the foreign keys to confirm the following requirements. So then the first case is about primary key. You need to define the primary key as not null values. Then the second one is foreign key. When we consider about foreign key, there are so many cases. Let's discuss about one case by case. The first case is M2N. That means many-to-many relationship. Both sides are mandatory as defined by a business rule. You can see in this case, many-to-many, both sides are mandatory. At that time, you decompose this into a one-to-many relationship like this. So when we consider about this decompose, that means student enroll in class. So you can see this is M to N, many to many, this is N. You can decompose it into a student one to many, enroll one to many, class. So you can see, you can map tables according to this ER diagram. There are three entities or three tables. The first one is the student number is the primary key, student name. Then the second one is enroll, class code, student number, enroll grade is the attribute. So the class, you can use class code, course code. These are the entities. So when we are mapping composite key into ER diagram or in ER diagram or in database, you need to indicate the primary key of this site and also a primary key of this site. These two get together to form primary key of this. That means composite key of this composite entity. Okay, so when we consider about these three tables, you can see the first one is about enroll table. When we consider about enroll table, these two came from this one. No, sorry, this table, and this is from this table. So these two get together to form a primary key of this composite attribute. So this cannot be null value, and as well as there are some delete restriction and update restriction. You cannot delete any class if it contains even one student. And to delete the class, we must first transfer all students into another class. So when we consider about enrolled table, you can see these two came from these two entities. So definitely it has delete and the update restriction. So on delete restrict and the on update cascade. So these are the restriction and the main scenarios about the enroll table. Then let's discuss about foreign key. This is about foreign key in class code. So you cannot delete a row in this table without deleting this one. At that time, it's definitely trigger the update or delete restriction from the database. Then let's consider about the next foreign key. It is about student number. It is came from this table. This is also not null. This is also cannot holds the null values, and also on delete restriction and on means on off. That means you can trigger on delete restriction and update cascade relationship. As example, we cannot delete a student if the student is only the one in the class, because in a mandatory relationship in the class must have at least one student. So we cannot delete this one. There is a direct reference, and this is a mandatory field. So at that time, this at least one student should be in. That means one student is. That means we cannot delete a student if the student is only the one in the class, because in the mandatory relationship, the class must have at least one student. Okay. You can easily identify the mandatory and optional when you are writing a cardinality. It is like 0n. Definitely it's the optional. At least one value as a minimum, it is mandatory. Okay. ඒ කියන්නේ ඔයාලා දැන් relationship type එක define කරන්න යන්න කලින් මෙතන මේ relationship type එක ගන්න cardinality කියනවානේ. cardinality එකේ මේ value එක minimum value එක 0 වෙලා තියෙනවා නම් ඒක optional. එහෙම නැතුව 1 වෙලා තියෙනවා නම් ඒක mandatory. එහෙමත් අපිට identify කරගන්න පුළුවන්. Then let's discuss about the second scenario. It is about both sides are optional and defined by a M to N relationship. Both sides are optional. So in this case, M to N, but both sides are mandatory. In this case, 1 to M to M, that means many to many, but both sides are optional. You can see, you can decompose it into like this: student, enroll, one to many, many to many. You can see this is 0. So this side is 0, mandatory. Okay. In this case, all have minimum value 1. So all these, for a student entity, class is mandatory. For a class entity, student is mandatory. But when we consider about this case, for a student entity, class is not mandatory. When we consider about class entity, student is not mandatory. Okay. So you can define a table: student, enroll. Is it clear? Is it clear?
Yes, madam.
Okay. Then you can see student, then the class code, student number. These are the available fields in the enroll. These are the available fields or attributes in the student. These are the available fields in the class. So you can see 3 entities. These are the attributes. You can see class code and this one. This is came from this table. This is came from this table. These two are get together to form a primary key of this table. So for an enroll table, both foreign keys, when consider about enroll table, these two are foreign key. So not null, it is definitely not null. On delete cascade and on update cascade available for this, because these are referred to another primary key for another table. If the relationship is optional, a class can exist even if contain no student. Similarly, a student may exist even if the student is not enrolled in a class. So these two are mandatory, sorry, optional. Class can be even without any student, even without any student, and the student can be exist without any class. So these are mandatory, but these two are came from this table and this table. So when you are deleting this one and this one, you can see it triggers some delete and the update. When deleting and updating, it trigger delete cascade and the update cascade. Okay. Is it clear? Is it clear?
Yes, madam. Yes, madam.
Okay. In this case, you can see delete restriction. You cannot delete this one, but in this case, you can see it's a restriction. At that time, this is a restriction. At that time, you can change or set the values into 0, and you can delete. You can delete these records from these two tables. That's because of these fields are optional. Then the next one is M to M, that means many to many. One side is optional and defined by as defined by a business rule. So then the next one is many to many, and one side is optional and another side is mandatory. In this case, you can see again the same example: student enrolls in class. You can convert this student enrolls in class like student enroll class. This is a many to many relationship. You can decompose it into a one to many relationship like this. At that time, you can see in this case one to many. The minimum number is 1, then the maximum number is n. So, but when we consider about this one, 0 and the minimum number of classes is equal to 0, maximum is n. So, this side is optional side because this value is 0. No? So, these are the again same tables. When we consider about these two table, you can see on delete cascade, not null, and the update cascade. You cannot delete when consider about enroll table. This table you can see on delete cascade and on update cascade. The comment is it is possible for a class not to have any students. So you can see this side optional. So you can have some classes without any students. So therefore, the deletion of a student on may be accompanied by the deletion of the student from the class. So if you need to create a class without a student, you can create it by deleting the student from the class, because it's not a mandatory field, it's a optional field. Okay, then the next one, it is about it is also about enrollment key. This is about student number, so this is about class code. So this is also same scenario, not null. Then on delete restriction, then on update cascade. So we do not want to delete the student from a class if that is students only is the only class on the student in enroll. The student must be enrolled in at least one class. When we consider about a student can have only one, at least have one class. So you cannot delete student. That means we do not want to delete the student from the class if that is the only class the student is enrolled. අපිට class එකක් delete කරන්න බෑ. ඒ ළමයා ඒකට සහභාගී වෙලා තියෙන එකම class එක නෑ. ඒ වෙලාවට අපි ඒක තියාගන්න. මෙන්න මේ විදිහට delete restriction එනවා. No need to memorize all these things. Just keep in mind foreign key එකයි primary key එකයි තියෙදි කොහොමද delete කරන්න පුළුවන්, කොහොමද delete කරන්න බැරි, කොහොමද කියලා මතක තියාගත්තම ඇති. Then about one to many. Next case is one to many. When consider about this one to many relationship, this is the department, employees, professor. This relationship is one to many. In this side, one department can have many employees. When we consider about one employee, he or she definitely belongs for one department. So this relationship is one to many relationship. So you can map tables of this relationship like this. Department, these are the attributes available in the department. This is the professor. These are the attributes available in this professor table. Then you can find primary key. So this is the primary key. This is the primary key of this scenario. There are two primary key from two tables. So let's discuss about deletion and the update of these two tables. So in this case, one to many. So when consider about many sites, that means professor, you can see professor number. This is the foreign key. You can indicate foreign key by dash line like this. This is the foreign key. So this is the primary key of this table. This is the primary key of this table. Then when we consider about the professor, you can see foreign key is step code. That means this is the foreign key. So you can see not null, on delete restriction, and on update cascade. We do not want to delete a professor if a department is deleted. First, we move a professor to another department. If you need to delete this one, if you need to delete the professor if the department is deleted. If you need to delete 1, 2, 3 value from, as example, 1, 2, 3 is computer science department. A is belong to computer science department. If you need to delete this one, first you can move this into another department as 1, 2, 4, or you can move this into a mathematics department. After that, you can delete this one. Okay, we do not want to delete the professor. If a department is deleted, first you can move the professor to another department. Okay. or you can delete. Yeah, you can delete according to this one. Okay, this is available in your book. This is the theory part. No need to go through all these things, but these are some rules available with the tables and the ER diagram. You can see, yeah, all the comments are also available in your book. I think this is so boring. So then let's discuss about this. In this case, both sides are mandatory. Okay. Room advice students. So when we consider about this relationship, room ID is a foreign key for student table. So these are the restrictions and the operations available on the student table. I think you have some idea about these things when you are doing SQL. This is about the querying thing. So you have some idea about when you are doing this practical part. So you can see this room number, room code is the primary key of this site, and student number is the primary key of this site. You can indicate room ID as a foreign key of this, room code as a foreign key of this table. So when we consider about the student table, that means this table, this is the foreign key, not allowed, on delete, set null, or restrict, on update, cascade. So when consider about this one, you can see these are mandatory, no? Sorry, these are optional, no? 0 and n, 0 and 1. So these are the restriction and the triggers available with this table. You can see if the room is deleted, the student cannot remain in the room and will in effect have no class null until he reassigned to another room. So when you are going to delete a room, at that time student does not have a room. Okay, and it is needed to assign him or her to another room. So restrict may be used to alert the user to reassign the student to another room. So these two fields are mandatory. So you can delete room. If this is not mandatory, that means, sorry, these two are optional. So you can delete a room. So if this is not a optional, this is not an optional entity. That means if this is a mandatory field, you cannot delete the row. So this is the optional. At that time, you can delete the room. So if there is a student in room 1, 2, 3, you can delete this one, and you need to reassign this student into another room. That is defined by these operations, the foreign key, not null, on delete, set null, or restrict, on update, cascade. You can, if you need to delete this one, you can set it into a 0, or you can update. You can update this, or you can update this room. Before that, you can reassign the student into another room. Okay, so this is about this one. Then the next case is one to many. You can see one to many. Again, one side is optional. In this case, both sides are optional. This case, all the sides are mandatory. But when we consider about this case, you can see professor advises students, this is mandatory. Sorry, this is optional. So you can see professor, this one, this is the table and the attributes available for professor entity. So these are the attributes available for student entity. You can see this is Can you all hear me clearly? I think
Yes, madam.
oh. Okay. Is it clear?
Yes, ma'am.
Okay. So,
Excuse me, madam.
yeah, go ahead.
Excuse me, ma'am.
Okay, but go ahead. Dilakshana.
මැඩම් මේ ඔය ඔතන ස්ටුඩන්ට්ලට ඔප්ෂනල් මාර්ක් එක දීලා තියෙන්නේ ඇයි මැඩම්?
දැන් මේ කේස් එකේ දැන් මේ ප්‍රොෆෙසර් ඇඩ්වයිස් කරනවානේ ස්ටුඩන්ට්ස්. එතකොට ප්‍රොෆෙසර් කෙනෙක්ට ඇඩ්වයිස් කරන්න ස්ටුඩන්ට් කෙනෙක් ඉන්නත් පුළුවන් නැති වෙන්නත් පුළුවන්. ප්‍රොෆෙසර්ව ගත්තම ඒ කියන්නේ අපි තමු ඇඩ්වයිස් එක නිකන් කවුන්සලින් වගේ ප්‍රොෆෙසර් කෙනෙක් කවුන්සිල් කරනවා ළමයින්ට. හැබැයි when ඔයාලා කන්සිඩර් කරද්දී ප්‍රොෆෙසර් මේ ප්‍රොෆෙසර්ට කවුන්සලින් කරන ස්ටුඩන්ට් කෙනෙක් ඉන්නත් පුළුවන් නැති වෙන්න පුළුවන්. ඒක ප්‍රශ්නයක් නෑ. දැන් ඔයාලා කැම්පස් එක ගත්තම කවුන්සලින් වලට ඉන්නේ ප්‍රොෆෙසර්ස්ලා 3-4 දෙනෙක්. හැම ප්‍රොෆෙසර් කෙනෙක්ම කවුන්සලින් කරන්නේ නෑනේ. ඒතර ප්‍රොෆෙසර් කියන එන්ටිටි එක ගත්තම ප්‍රොෆෙසර් කියන එන්ටිටි එකට ස්ටුඩන්ට් කෙනෙක් කවුන්සිල් කරන්න ඉන්නත් පුළුවන් නැති වෙන්නත් පුළුවන්. ඒතකොට ස්ටුඩන්ට් කියන එක ෆීල්ඩ් එක මෙන්න මේ ප්‍රොෆෙසර් කියන එක්කෙනාට ඔප්ෂනල් මෙන්න මේ ඇඩ්වයිස් කියන රිලේෂන්ෂිප් එකේදී. හරිද? අන්න ඒ නිසා තමයි අපි මේව ඔප්ෂනල් කියලා කියන්නේ. හදිස්සියවත් මෙහෙම නීතියක් තිබ්බොත් හැම ප්‍රොෆෙසර් කෙනෙක්ම කවුරු හරි ස්ටුඩන්ට් කෙනෙක්ට ඇඩ්වයිස් කරන්න ඕනි කියලා. ඒතකොට මෙයාව අපිට ඔප්ෂනල් කියලා ගන්න බෑ.
මැඩම් දැන් සාමාන්‍යයෙන් දැන් අර මැඩම් කිව්ව විදිහට මේ දැන් බිඳුව තියනවා නන්නේ මැඩම් ඒක ඔප්ෂනල් වෙන්නේ.
මේකේ
එතකොට ඒකේ මාර්ක් එක දාන්න ඕන බිඳුව තියෙන පැත්තේනේ. දැන් මේකේ 1 to 1 මේ එකේනේ රිලේෂන් එකේනේ දාලා තියෙන්නේ.
ඒක පොඩ්ඩක් මෙතන වරදලා. wait. When consider about one professor can have many students or a zero number of students. So when we consider about a student definitely පටලවලද කිව්වේ එක නෑනේ. mandatory field එකක්. wait. නෑ මමයි පටලවලා කියලා තියෙන්නේ. ඒක මේ අර අපි දැන් කාඩිනල් ටික මාරු කරලානේ බලන්න. දැන් මේකෙදි මෙයාට මේ ක්ලාස් කියන එක්කෙනාවට මෙයා ස්ටුඩන්ට් කියන එක්කෙනා කියන්නේ මේ පැත්ත 0 වෙනවනේ. ස්ටුඩන්ට් කියන එක්කෙනාට ක්ලාස් කියන එකක් තියෙන්න පුළුවන් නැති වෙන්නත් පුළුවන් නම් මේ පැත්තෙන් අපි දැන් ලියන්නේ 09 කියලා 0 පැත්තට විරුද්ධ පැත්තේ. හොඳේ. ඒක පටලවා ගන්න. sorry මට පැටළුනේ. දැන් එතකොට මේකට විරුද්ධ පැත්ත දැන් අපි මෙයාගේ කාඩිනල් ටික සෙලකුවම් wait. this one මෙන්න මෙයාට කාඩිනල් ටික example එකට වෙනස් කරලානේ. මේ මම ගත්තේ ඔයාලගේ පොතේ තිබ්බ examples ඒ විදිහටම. මම ස්ලයිඩ්ස් ටික මම හදපු ස්ලයිඩ්ස් ටික ගන්නෙ. ඔයාලට පුළුවන් මෙන්න. දැන් මෙයාව 0 වෙනවා නම් මේ පැත්ත තමයි ඔප්ෂනල් වෙන්නේ. අයිද ප්‍රොෆෙසර් කෙනෙක්ට ඉන්නත් පුළුවන් ස්ටුඩන්ට් කෙනෙක් නැති වෙන්නත් පුළුවන්. ඒතකොට ස්ටුඩන්ට් ගේ පැත්ත තමයි මෙයා වෙන්නේ. sorry මේ ඔයාලා කාඩිනල් ටිකෙන් අයිඩෙන්ටිෆයි කරගන්න එපා. ස්ටුඩන්ට් when you consider about a professor කෙනෙක්ට ස්ටුඩන්ට් කෙනෙක් ඉන්නත් පුළුවන් නැති වෙන්නත් පුළුවන්. ඒතකොට ස්ටුඩන්ට් කියන ෆීල්ඩ් එක තමයි මේවා වෙන්නේ. මෙයාට අදාළව අපි කාඩිනල් ටික බලන්නේ මේ පැත්තෙන්. අන්න ඒකයි මට පැටළුනේ ඉස්සලා. මේ පැත්තේ කාඩිනල් ටික 0 නම් හරි. කාඩිනල් ටික 0 නම් definitely එයාව මේ ස්ටුඩන්ට් කෙනෙක් මෙයාව වෙන්න අපි කාඩිනල් ටික ක්‍රොස් කරලානේ ගන්න. එතකොට මේ පැත්තේ කාඩිනල් ටික සරකන්න ඕනේ. කියන්නේ ඔයාලට හදිස්සියව දීලා තිබ්බොත් මේ වගේ එකක් A B කියලා මෙතන අපි හිතමු 0 sorry මෙතන තිබ්බ කියලා 0 1 මෙතන තිබ්බ කියලා 1 1 at that time this should be a optional one. Okay, got it?
ඔව් මැඩම්.
ඒ කියන්නේ විරුද්ධ පැත්තේ. as an example again when consider about this optional and the mandatory field, you can see this is the relationship A and B. When consider about minimum cardinality from this side 0 and 2 and this is 2 and that minus 1 and many, at that time you can see this is 0. See, this A when consider about A, this B is optional for A, that's denoted in this side. So when we consider about 0 in this side, definitely optional sign is in other side. Okay.
Okay, madam. Thank you, madam.
Yes. Are there any other doubts? Sorry, ඒක මට පැටලුනේ කියද්දි. So it is my mistake. Do you have any other questions about these things before moving to next one?
No. Okay, madam.
Okay, then the
Please explain the case 5 again.
sorry.
Ma'am,
Oh,
please explain case 5 again, please.
5. Okay. This okay. So in this case, okay, so in this case 5, 1 to many, in the both sides are optional. You can see in this case, the student and the room, there are two entities, and the advisor. So this is wrong. I think it's according to your book. Case 5, no, this is not ad. Let's take this one. Students are in a relationship like this. So you can see room and the students. So when we consider about room and the students, room is optional for student entity, and when we consider about student entity, room is optional for this one. So you can see minimum cardinality is equal to 0, 9. So this is optional. 0, 1. This is optional. So these two are optional, but this is in one to many relationship. At that time, you need to indicate room ID in this side. Okay, room code, then the building code. You can see this is the student number, student last name, first name, initial, and you can indicate room code as foreign key. So when we consider about student table, this room code is foreign key. This is a foreign key. Okay. When consider about this one, not allowed to have null value. So this is a condition, not allowed to have null value because this is a primary key from this one, and this is the condition, not allowed. At that time you can delete. That means if a room is deleted, the student cannot remain in the room. If these two are optional, but you are going to delete this room, as example, room number 1, student is 215. So if you delete this one, this student cannot be in this room. At that time, database trigger a triggering message or a cascade on this one. Set to null, delete, set null, or restrict on update cascade. These two are the cascade or a restriction triggered by the database. They said that you can reassign this student into another room. So if the room is deleted, the student cannot remain in that room and will in effect have no room until he is reassigned to another room. Restrict may be used to alert the user to reassign the student to another room. Okay. So this room code is from this one. If you need to delete this one, you need to reassign this student into another room. After that, you can delete this one. This is about on delete set null, or you can set into a null value. So in this case, that is also needed to indicate. You can reassign this student into another table. So you can set it 0 because these two fields are optional fields. So you can that means you can remove the student from that class and you can delete that one. At that time, you can make the database value into a 0. Okay, that's described by this one. On delete set null, you can set the value into null, or you can create a restriction. Restriction is defined in this comment. Okay, දැන් අපි delete කරද්දී අපිට පුළුවන් දැන් අපි මේ mandatory field එකක් නෙවෙයි optional field එකක් නේ. ඒ නිසා optional නිසා අපිට ඒව 0 කරන්න පුළුවන්. එහෙම නැත්නම් අපිට පුළුවන් ඒ ළමයාව වෙන එකකට assign කරන්න කියලා database එක trigger කරන්න triggering message එකක්. Is it okay? Damayanti, I think.
Okay, ma'am. Thank you.
Then this one. Yeah. When considering about the case number 6, you can see the professor advises students. So when consider about the professor and the students, so no needed to have a student for professor to advise. So this is an optional field. You can see student number is a primary key, professor number is a primary key of these two tables. This professor last name, professor first name, and the professor initials are the attributes available in the professor table, and these are the attributes available in the student table. This is the primary key, this is also primary key. Professor number is a foreign key. You can indicate foreign key by using a dash line. Okay, then let's discuss about operations available on student table. When consider about a student table, when consider about professor number cannot be a null value. Then yeah, student null value, on delete restriction, and on update cascade. We do not want to delete a student if the professor is deleted. First move the student to another advisor. Okay, so the student is not a mandatory field for a professor. No, if you need to delete the professor, at that time you can move this student into another professor, because the professor is not a mandatory, that means student is not a mandatory field for the professor. At that time you can move that student into another professor and you can delete that professor. So you can see at that time on delete restrictions available, on update cascade. Okay, if this side also which means if the scenario define this side also optional field, at that time you can set this value into a null or a 0. Okay, then about one to many. One side is optional and one to many, one side optional and many side mandatory. So when we consider about one to many, one side is optional and the many side is mandatory. Okay, in this case you can indicate gallery ID. In this case, this is a many side, no? So you can include gallery ID as a foreign key of painting table. Painting number is a primary key. Gallery number is a foreign key. Gallery number is a primary key of gallery table, and these are the other attributes available in this one. So let's consider about painting one, this table. So when we consider about this table, gallery is a optional one. So gallery number can have a value or cannot have values. That means that this field can have or cannot have. That means this field can have any value or this field can be a null value. So you can see null allowed. At that time you can see null is allowed, because this is a optional field. So you can include gallery 0 values to this gallery number, because this is a optional field. Okay, on delete set null, at that time if you need to delete, you can make the gallery number into 0 and you can delete it. And you can see when you are updating this one, you can update this gallery number into 0. After that, you can update this one. So we do not want to delete the painting. If we delete the gallery number is painting may be set to null. The restriction declares might be used to alert user to possibility of deleting a gallery that still containing paintings. This is an optional field. So due to this attribute can have null values. So if you need to delete one value from the gallery table, you can delete it. Before that, you can set this gallery number into 0. After that, you can delete it. If you need to modify this one, you can set the gallery number into 0 and you can update this one. So in this case, it's allow null value and also on delete set null or restriction. ඔයාලට null value එකකට set කරන්න පුළුවන්. එහෙම නැත්නම් ඒ value එක දැන් අපි හිතමු as example, this is 256, this is 256. You can set into a 0, you can delete this. After that, you can delete this one. This is the one way, or you can directly move this into a 0 and then you can delete this one. There are two ways in deleting case. Set null or you can restrict. Then you can have update cascade to update this one. You can first update this one and after you can update this one. In this case, we do not want to delete the painting. If we delete the gallery number painting may be set to null because this is a optional field. Okay. Then case number 8 is this about one-to-one site. Before that, do you have any questions? Do you have any questions? No questions? Okay. One-to-one relationship. When we consider about one-to-one, in this case, both sides are.
Madam, can't hear you.
Can you hear me now?
Not yet, ma'am.
What about now?
Oh, okay, ma'am.
Then let's discuss about one-to-one. In this case, both sides are mandatory. So the professor is an professor. What is this? So this is the case number 8. Yeah. So you can take this like this. Professor has a room. Okay. There are so many mistakes in your book. No? So you can take this as professor has a room. When we consider about a professor, one professor can have only one room. When you consider about one room is allocated only for one professor. So this relationship is one-to-one. So when we consider about one-to-one and these two entities are strong entity, that means mandatory entity, no optional. So these are mandatory. So you can take the attributes as professor, professor number, professor last name, professor first name, professor initial, and the room code. Then about room, when consider about room code and building code are the fields or attributes available in these relationships. Are there any foreign keys available in this relationship? sorry, this is 1 to 1. So you can see this is the primary key, this is a primary key, no foreign key available in this relationship. Okay. So when consider about this one, wait, room code. So sorry, when consider about this one, so there is a link between these two tables, so one-to-one relationship. When we consider about a professor, professor is allocated for a room, so the room number is foreign key for this professor entity. So when we consider about one to many, it's definitely one side foreign key, sorry, primary key can be inserted into many sides. But in this case, one to one, so the room code is the linking attribute between these two. So you can see this room code can be taken as a foreign key of this one. Okay. So when consider about professor, professor number is the primary key, room code is the foreign key. You all know when you consider about a professor, this professor has, when consider about a professor, professor has unique room or a unique room. So you can see this room code is foreign key for professor entity. So you can see, let's consider about professor table, room code is a foreign key. This cannot be null. Definitely when consider about a room, this is a mandatory field. Every professor has a room, and when consider about room, this room is allocated for a particular professor, so these two are mandatory, so this value cannot be null. So it is needed to contain any value for this attribute, not null value. So when consider about on delete restriction and on update cascade, so you can see deleting restriction and updating cascades are available with this table because this room code is from another table. So we do not want to delete the room if it is assigned to the professor. We must first move the professor to another room. So you cannot delete the room if there is a professor in that room. At that time, first you can move the professor into another room. After that, you can delete the professor from the room. So in this case, if you need to delete the room code 12, you can take 12 Janaka. So you can move Janaka, Professor Janaka into room number 13. After that, you can remove this one. You can delete this one. You cannot set it into a null value. Definitely you need to move it into another room because this is a mandatory field. Okay. Then one-to-one relationship, both sides are optional. In this case, you can see this relationship is one-to-one. So both sides are optional. PC operated by the professor. When we consider about the PC, PC can be operated PC can be operated by a professor or any other person. So this relationship is one-to-one, and this is not a mandatory relationship. These are optional. So when we consider about these two, one-to-one, so the PC number is the primary key of this table, and when we consider about professor, professor number is a foreign key of this table. The professor number, professor last name, professor if name, and the professor initial. There are some cases, this is from this side to this side. If you write this professor into this side and PC into this side, you can take PC number as a foreign key in the professor side. That's up to you. So you can see this is the foreign key. The foreign key is professor number. Null are allowed because these two fields are when consider about these two fields are optional fields, so it is allowed to have null values for these two fields in the table. and on delete set null. If you need to delete a PC from the PC table, so if you need to delete a professor, yeah, the professor does not necessarily to operate a personal computer. Or no, if the PC is necessary to assign a professor. If a professor is deleted, then the professor number is set to null in the PC entity. So as an example, let's take these two are optional. If you are going to delete this professor, so you can set this professor number into 0 and you can delete that one. Okay. Then the next one, it is about one-to-one, but one side is mandatory, this side is mandatory. So professor is in a room. So when we consider about a professor is in a room, and we consider about the professor can have a maximum number of room is equal to 1 and the minimum number of room is equal to 1. When we consider about a room can have a professor or it cannot have any professor. So when we consider about this one, professor is optional for room entity. ඒ කියන්නේ අපිට room එක professor කෙනෙක් ඉන්නත් පුළුවන්, room එක professor කෙනෙක් ඉන්නත් පුළුවන්. So the professor entity is optional for room entity. So 0, 1. So this professor entity is optional. You can indicate attributes as a professor number, professor last name, professor first name, then the professor initial, then the room code. These are the available attributes in the professor entity. Then the room code and the building code. This is the primary key. This is the foreign key. When we consider, sorry, this is the primary key of this table. This is the primary key of this table. This is the foreign key of this table. This is from this table. Okay, so let's discuss about the foreign key on the optional entity, this one. So when we consider about this one, room code. So when we consider about professor, this is about professor, not this is the foreign key on about the optional entity, that means this one. When we consider about professor, this is the foreign key, not null, on delete restriction and on update cascade. We do not want to delete a room if it is assigned to a professor. First reassign the professor in a new room and then you can delete the current room. So it is definitely this professor. When consider about professor is depend on this room. So professor need a room. Definitely professor need a room, but when we consider about a room, it can allocate for a professor or it cannot allocate, it does not allocate. That means room can be with the professor or without a professor, but when we consider about a professor, definitely professor is in a room. So this is mandatory when comparing to this one. So when consider about the professor entity, you cannot have any null values for professor entity, and there are some restriction on delete restriction. You cannot delete a professor, you cannot delete a room without assigning a professor into another room, and you cannot update the room number without changing the room number of the professor. That means before deleting a room, you need to reassign the professor into another table, sorry, another room. Then when we consider about this one, mandatory field, this one. So when we consider about mandatory field, this is not a necessary entity. That means this is not depend on professor. So this is allowed null value. So when we consider about room, the professor room can, that means in room you can see a professor, you can't see a professor. So this room is optional field, so it can allow null value. So at that time, if you need to, the room is a mandatory the professor, but the room might be an empty. If a professor assigned to a particular room is deleted, that room will be vacant. So you can see if you are going to delete this professor from this room, you can set the room value into 0 because professor is an optional field. So these are the two operations available in the tables. Then the last one is weak entity, not a last one. No? When consider about a weak entity, you can see employee has dependent. This is a weak entity. Employee number, employee last name, first name, and the initial, then the employee date of birth. When consider about weak entity maintain, that means weak entity maintain department number and the employee number. That means employee number and the department number as the primary key, the combination of two attributes. This is the primary key, and this is the foreign key. When consider about the employee number, it is a foreign key because this is belongs to this table, or this is a foreign key, but these two tables get together to form the primary key of this table. This is the dependent number. So because this is totally different, this depender is totally dependent on employee. This depender cannot exist without employee. That's why we indicate this employee number as the primary key of this table. So if you need, yeah, let's consider about this foreign key as a foreign key. You can see not null values. You cannot have any null values because this is a primary key of this table. This makes some contribution to form a primary key of this table because this one is totally depend on this one. So at that time you are not allowed to have null values for this entity, this attribute, and you can see delete cascade and update cascade. If the employee is deleted, the employee's dependent must also be deleted. Depend on other entity, and dependent is a weak entity of this weak entity. So if you are deleting this one, definitely this.
Madam, we can't hear you.
Now, can you hear? What about now? Can you hear me?
Now okay, ma'am.
Sorry?
Now okay.
Okay. Then when consider about a weak entity and a strong entity, you can see this weak entity is totally depend on the strong entity. So you cannot, you can see this entity cannot exist without this employee entity. So if you are going to delete this employee records, definitely you need to delete this dependent record. So if the employee is deleted, the employee's dependent must also be deleted. Then the last one is multi-value attribute. In this case, you can see new table. This is also one-to-many table. You can see. This is a car. Car number is available. This is the car. Then the car address. This is not a car has colors. This relationship like has anything. Car advises the color. So you can see this is a optional one. So if you consider about the foreign key, this is a many site, so you can include the car number as a foreign key of these sites and the color ID as the primary key. So you can set this value. You can set this foreign key into 0 because this is not a mandatory field. So you can set it 0 and you can delete it. Okay. So this is all about developing an ER diagram. So it is needed to have some idea about how to develop a ER diagram as well as how you can convert this ER diagram into a database. So do you have any questions? Do you have any questions? Do you have any questions? No one in the class? It's all Maybe 62 students, no? Is this lesson so difficult?
Madam, will this lesson come to Cat 1 paper also?
From lesson 1 to 13.
13.
Database tables and the normalization. Today we discussed about developing a diagram. So now
Can hear, madam.
okay. CAT exam is on 16th November. Most probably it's a home assignment. You can go through the lessons from 1 to 13 before the CAT exam. That means before the home assignment. Today I already finished lesson number 12, developing an ER diagram. Tomorrow let's discuss about tables and their normalization. Before that, do you have any doubt? එකෙන් අපිට මෙතනින් ඉස්සරහට කන්ටිනියු කරන් යන්න බෑ ER diagram වල මොන හරි ප්‍රශ්න තියෙනවා නේ. ඔයාලට ER diagram එකක් දුන්නොත් ඇඳ ගන්න පුළුවන් වේද? Can you draw a ER diagram for a given scenario?
Yes, madam.